Hello and good morning to everybody.
Hello from my side as well. Good morning from K2 from Renningen.
And welcome to our webinar for seam roofs and Dome V system for flat roofs. My name is Matthias Rentschler. I'm working in the product management since February, and this is my colleague Roman, and he will talk a little bit about himself.
My name is Roman. As some of you maybe know me already, I'm working in the technical department. My responsibility is for the Benelux area. I'm working for like the Netherlands, Belgium, or Luxembourg, also as well as West Germany. All right, today, as he already said, we are talking about flat roof systems, again, the Dome V systems, and also the new base update for the clamp systems, like the seam roofs. All right, Matthias, shall we start with the presentation?
Yeah, but before we start, if you have some questions, please just write us the questions in your text field in the message. Then we can read it and hopefully we can answer it directly in the webinar. If there are too much questions, we can answer them later on after the webinar because we have your contact details.
That's right. We try to answer them right away. Otherwise, just send an email. We will definitely get back to you. All right, let's start it.
Let's start. We'll just change the presentation.
Let's change it.
So this will be the agenda for today's webinar. We would like to talk about standing seam roofs first. And we'll start with a presentation, short, just 2-3 foils, nothing big. I think it is better later on if we show you the parts directly in a live show, the samples. And after that, Roman will go into base on, and we will show you an example of planning in base on. After that, we will go to the flat roof systems with the Dome V. So we will do the same. We'll go into the presentation of the D-Dome V and the S-Dome V. We will show you the samples live in a live show, and we'll do a planning for flat roofs, also in base on. Let's start with the standing seam roofs. Now, I think most important, we have the seam roof clamps for our solid rail, which is quite well known by most of the customers. And now new, we have also the seam roofs for the single rail system. Later on, we show you in a live demonstration why we have this. We have a lot of different clamps for standing seams, for the most common standing seams, and we have them in aluminum and in a steel version. We'll show you in the presentation only 2 examples for standing seam room and for a round seam. We also have for almost every seam roofs a solution. And if you don't know which roof you have exactly, just take a photo from the profile, send it to us. Roman can have a look at a picture.
I will have a look at it, or the other guys from the technical department. I think you all have one person to contact. It's just easy. Send a photo. If you don't know which one you have, we will figure it out and send you a message back.
For sure. So the solution for the solid rail, you can see the clamps on the left, the standing seam clamp and the round seam clamp. How you assemble them, you can use a T-bolt, but this, as I told already, are only samples. We have a lot of more clamps in our portfolio. So later on we see it, or we can see it also in base on how many clamps we have for the different roof types. And how you assemble it, we will show you later on in a live demonstration. The same we have for the single rail. It's also just 2 samples, the DS MIDI for the standing seam and the R MIDI for the round seam.
All right, can I introduce the MIDI clamps? They are very new. Sorry to jump in, Matthias, but they are very new for the systems. They're very convenient. They have a lot of good reviews so far. Like a lot of people tried them already. They're very easy to install. They're very fast fixed, and yeah, they're just perfect way.
Yeah, that's the most important thing. They're easy to install with the climber solution, and I think this is really a good solution what we have now. So let's have a look for some references of some installations with the standing seam clamps. So you can see the clamp or the standing seam clamp and the rail on top of it. And on the picture on the top, you can see also the module clamps which are used to fix the modules.
All right, there's a question in between. Just 1 second, Matthias. The question was if the system is waterproof. Of course it is. There's nothing ever can happen with that system. The clamps are just, yeah, they're waterproof. If the rain is falling down, if you, I don't know, chuck a bottle of water on it, nothing will happen at all.
That's true. So let's change to a live demonstration. I think this is the more interesting part than just have a PowerPoint presentation.
All right, camera is set. You can see us quite well. All right, Matthias, you want to start?
Yeah,
let's start with the solid rail.
Let's start with the solid rail. So this is the solid rail system. And these are the clamps. You can see the clamp for standing seam, which we have here, and the clamp for round seam.
Those are not all the clamps we're having. As he said already before, our portfolio is way bigger. That's just 2 samples we're having here, otherwise it would be too long.
And how to assemble it, it's quite easy. Just use the T-bolt, and then you can just turn it in the rail. Sure, normally the clamp is already installed on the roof, but
That's
now
right.
you can do it like this. And then take the
nut.
Yeah, just put it on, and then it's installed.
Tighten it up, and it's installed.
Tighten it up, it's quite easy.
Still very easy, still good. The same way with the round clamp, it's exactly the same part. You tighten it up from the bottom, so this is maybe a disadvantage, otherwise perfect system.
And you can still move the rail.
That's right.
If
it's not in the right position, you can still move it around after you already fix it in. Easy going.
Easy going. So
okay,
let's have a look at a single rail.
Let's have a look. Single rail. I think a lot of you know that one already. It's just one profile on the side. We actually hook it in. Let's go to the clamps first. This is the first sample. We have the DS MIDI clamp. Also, it's very easy to remember DS for double seam. You can use it as a single seam as well. But just for seam roofs, single DS MIDI. It's very easy to fix it. You take the single rail, use the climber, and tighten the nut. After it's fixed, you can still move it forth and back. And otherwise, if it's in the right position, you tighten it up. Done. This is the DS MIDI clamp. Same thing with the round MIDI clamp. See, it's a bit wider. The R MIDI clamp, sorry. Little reminder, round for R. You can have it in a round seam. Yeah, sorry. This is how I remember it. I think that's the easiest way. Same way, you fix it into the rail profile on the side, tighten up the nut, still move it around in the right position. Well, in this way, we actually move the rail, not the clamp, because the clamp would be fixed already. Tighten it up completely, and it's done. This is how it looks from all the sides. The advantage is you have to tighten it from the side. It's very easy for the installer, not like the solid rail system. You have to tighten it from the bottom. This is the difference, biggest difference. Also, what's very new, you will see it later in base on, we have implemented the end cap. Those little plastic caps for the end of the rail looks nice, no sharp edges anymore. It's already installed in base on now. This is for the new version. It's just to mention it, right? Matthias, anything else you want to say?
No, I think we can start with a base on planning.
All right, let's do the planning then. Let's change the camera to the screen again. There's a question about the maximum gust wind speed. It depends on which area you're in. Usually all the data are implemented in base on already. So if you type it into base on, they will tell you if it's overloaded or if it's still enough. But the maximum gust, you can't tell a value just like that just now.
Yeah, I think during the base on presentation, we can see how much wind it can handle. And then we can have a look also.
All right.
What's the capacity of the system?
Right. Okay, let's start. I hope everyone has already registered in base on. Everyone has signed in, as I did as a webinar moderator. Everyone has its language set. And I hope all of you have done calculations before, so I don't have to start from the very beginning. Otherwise, just send us a message. We will get back to you, okay? All right, let's start with a new project, as we always do it. Oh, before I start, very important, if you see on this screen right in the middle of on base on, there's always news about K2. If there's an update for base on, if there's just anything new, please don't ignore it, read it. It's very important for us. You will save time to call us, we will save time to send emails. Sometimes questions are just answered by reading it. Okay, let's.
And if you're not registered, you can just do it. It's free of charge. Just register yourself and then you can try everything.
Good point, Matthias. All right, you guys are ready? Let's start with the calculation. Want to do a new project? Nothing saved yet, so we can just press OK. And then we will go, first of all, for the location. Very important, as we had the question before, we need the loads, like the wind loads, the snow loads, and they're all implemented into base on. So if you have the right address or just the right area, it will download the right values. That's why it's very important to have at least the area assigned in. We are having a project in Renningen today. This is where we are based. I can show you where our office is right here, CK2 Systems. So we know all these buildings. That's how we know that this is a right seam roof. We call the project just test. That's what we're doing now. The author, that's me. I'm Roman again, sorry. And the customer, just another test, right? Okay. What I'm doing at the very beginning, if I've filled everything in, very important to save it in between. Some people don't save it the whole way through, and then the internet's stuck, or the PC is not working quite well, or anything else is hanging up. So you have the problem, the whole project is gone. That's why a big clue, please save it in between all the time. All right, first one is filled in. Let's go for the next step. To the roof. We press the plus button. Today we want to do a gable roof, rectangle, and seam metal. So this is the new feature. This is what we're doing now. We add the roof and start drawing it. Okay, now you can see there's an arrow in the middle of the roof. This is the direction of the inclination. So for now, we have the east side of the roof, means our inclination is going to the right-hand side. We can change this direction by pressing the plus or minus button on the left. Let's just do this now. Okay, this is pretty much, you can always think about the water. Water is flowing down this direction now. As we know the roof, we have the values. It's 8 meters high. It's 12 degrees on the pitch and the inclination. And we chose the seam metal. If you press the wrong button, you could still change it up to trapezoidal or tile, but we want to do the seam metal today. Now, Matthias is telling you on the presentation, we have a lot of different seams. Yes, the question came up, the arrow is the water flow direction. That's right, that's right. What I wanted to say is this one, the seam type, if you press this button, it will give you an idea about how many different types we're having implemented into base on. A lot of very popular ones like rib roof or Dome or even klip-lok. They're all different types of roof, and you can just press it in whatever you want, which one you have for sure. Today we want to do the calcip, also very famous and popular. A lot of you know calcip roofs. The only thing we have to type in is the seam distance. Let's say that's 400 millimeters. On other roofs, if it's not a calcip roof, you would have to type in the seam thickness, seam height, and sheet thickness. Very important for the stability of the roof. If you don't have the material of the roof, you always choose the weakest one, which is, in this case, aluminum. So we keep it with aluminum just to see how it works. After you've done that, you switch to 2D view. Type in the right measurements, the right dimensions of the roof. We know we have 18.5 meters long, and the depth of the roof is 6 meters. After you've done that, you can see if you switch to map view, it shows you a different dimension, but this is the view from the top now with the inclination. Don't worry if you switch back to 2D, it's the same length like you typed in before. All right, if you have obstructions, like obstacles, like a chimney on your roof, you can draw that one over here. But for the seam roofs, we don't have any for now. We will get back to this with the flat roofs later. The remarks, you can just write something in for your customers. For example, the assumed values, if you don't get the right values of your customer, and you have to assume them. So after I've done that, I will just save it again. Better one more step, then lose the whole project.
Yeah.
All right, we will switch over to design, and this is where you choose your module. There are a lot of modules in our database. You can see all the brands. Today we want to go with Hanwha and keep the Hanwha Q cells. There's different types of Hanwha Q cells. We just take the first one. If your module is not in the list, you can just press user define, type in the name of your module and the width and the length.
Yeah, the name is not really necessary for us, but for us necessary to do the right calculation is the dimensions of the module, so the length, the width, and the frame height. Also the weight to calculate the clamps and the rails and everything. We need the weight. And the output power is just for your information, and you can see later on what's the output power of the complete project.
Exactly.
Because we know how many modules are inside. So these are the important points for us.
Yes, that's right. All right, let's go. For Hanwha Q cells again, let's say 300 watt, and then start with the calculation itself, with the module field. We press the plus button again, and we all know the solid rail, so today we want to go for the single rail. It's the easier solution, as we saw before on the presentation, also with the samples. So we like to go with the single rail. Parallel is already typed in before. It's a default in the system. We want to go for portrait, otherwise we would have a 2-layer system with a cross bracing. And then we like to go for the module field.
I think this is quite important to choose a module field. You can also choose the complete roof, so we just put modules on the complete roof. But if you want to change later on something, then most of the time you have to delete the module field and have to start from this layer now. If you have, or start now with a module field directly, then you can change it later on easily.
Exactly. If you have to adapt something, if you have to delete out modules, if you have to, I don't know, if you have to draw the module field smaller than it actually is because the roof is smaller, you won't have any problems if you draw the module field. So that's what we're doing now. We edit and then draw it from the top left corner to the bottom right corner. And there we go. We see now 5 module blocks. 4 with the same size and just one single one. We don't really like that layout, do you, Matthias?
No, not really. I don't like it on the right. Just 3 modules, single modules.
They don't look good. They don't look good.
Yeah.
So we want to have exactly the same amount if it's possible. If not, we just want to have it look right. So what we do is we try to fix 6 modules next to each other. This is the maximum you can do with the rail length before you need to have a thermal gap.
Important, the software knows the maximum. So if you would like to type in 10, for example, it will go down to 6.
Okay,
so
I can show this. Let's try to put 10 next to each other. It's not possible. The base on knows what's the maximum and it will show you. Then you can change the thermal gap width, like let's say 500, gets bigger and wider. This is very convenient if you want to have the service aisle, like for example for the maintenance, or if you want to check and clean the modules. Let's go back to 150 millimeters. That's enough for now. So what we see is now we have a block of 6 modules next to each other, another 6 modules next to each other, but then we have 5. We want to have it look really symmetric. Yeah. So that's why we want to have the module with 5 blocks, sorry, the block with 5 modules in the middle. That's why we changed the thermal gap into here. You see all the lines, the red lines. This is where you can have a thermal gap, but there is none so far. So you press on one of the red lines, it turns yellow, orange-ish, and you tick that little box. There we go. We will have another thermal gap. So we don't need this one anymore. It doesn't look good. We have a single row now. So we press it again, press this white line, turns yellow again, tick the box. You see how it's getting thinner, and we don't have a thermal gap anymore. So now it's looking quite good. The building is just 8 meters high. Maybe there are buildings around, and they can always see it. So yeah, this is looking much better.
Yeah, so we have one question to the thermal gaps. The question is, what is the minimum thermal gap? I think we can just check it. If you type in 10 millimeters, for example.
Let's type in 10. It will turn into 110. This is the minimum gap, but it's from system to system different. This is not just the basic value. You just have to try it with every system. Same for the thermal gap vertically. Sorry, it's vertically. I'm getting confused here. The thermal gap has to be only 80 millimeters, as you see. So this is different from system to system. All right, so this is what we have now. 3 nice looking module blocks. Looks good on the roof. Looks symmetric. There we go on. You could still change it up from portrait to landscape or clamming on the short side, but that's what we don't want to do this for now. Doesn't make sense to have a cross bracing here. Next step would be going for the loads. You see, you can double check what you filled in, the location and everything. And while you type in the proper location, the right one, you see the wind load was downloaded automatically and the snow load as well. So there we go for the results. You see, if there's another clamp possible, you could change it here. Single rail, if it's too weak, the 36, you go for the 50, and then you can change the rail length.
And you see already the end caps. If you'd like to order the end caps, just tick it there, or
it is already, yeah. If you untick the box, you don't have them in your article list, but they're already ticked in the box. So this is a new feature of Base-On. All right, then the summary. You see the whole bill of materials. You see, we just wrote one roof. If you had another, or 3 or 4, you would see all of them here, and then the just total amount of modules you're drawing. Then it's just generate the PDF file for now, so you can see what you get at the end. first page with your name, the project, and the date. And it goes on. You can double check all your values and data you typed in, the modules you're having, the amount of modules, and then the assembly plan. How many rails you need with this length, so the quantity of 4 meter 15, and then the rest what you have to cut. There's the layout again, and then the fixation points, and that's it. There's another table with the loads, structure analysis report, which is pretty much just everything which is written on the top already. Snow load, and then the calculation. How is it based? At the end, you will see the bill of materials. If you have more than one roof, you will see after every roof, you will see a bill of materials, and then one whole one at the very end of the PDF file.
And I think important, directly before the bill of material, there's one sentence which is quite important. The system has been successfully calculated. So with this system, everything is okay.
Exactly. Like with the rails and the whole roof, the whole system is verified pretty much. That's it. Okay, I think that's enough for the pitched roof, for the C-metal roofs. We have to keep going with the flat roofs. Matthias, what did you say?
Yeah, somebody else has a question for the seam roofs.
All right, if there are more questions, please ask them now. Otherwise, we would go forward to the next topic.
Yeah.
I don't think there are more questions, so must be everything clear. Hopefully we get a lot of requests then with base on already calculated. All right, let's go to the next point then.
So let's go to the flat roof systems. One more time, back to the group presentation. The flat roof systems, we changed now, maybe half a year ago. And we changed to the new Dome V system. The Dome V system is a short rail system, and we have two possibilities how you can install them. The first is the D-Dome. This is for the east-west direction. And there you can also see the V, hopefully. Yeah, this is the V. So this is called a Dome V system. And we have the S-Dome V system, which is for the south direction or for single direction. And this is, you can see on the picture on the right. So S-Dome V and D-Dome V, both are inclinated with 10 degrees. So the D-Dome and the S-Dome are inclinated with 10 degrees. What is new on this system? So first, it's a short rail system. Short rails is really good for the absorption of tolerances. So aluminium has tolerances, aluminium is moving, and with the short rail system, we can absorb the tolerances.
Just sorry, one question came in. What's the maximum inclination for the S and D dome? We have 10 degrees for now, but we are working on maybe getting 15 degrees as I know. I don't want to promise this now, but I think 15 degrees will be coming soon. But for now, 10 degrees it's it.
I think so. Or if you mean the inclination of the roof, because I'm not sure at the moment, the inclination of the roof at the moment, the maximum is 3 degrees.
5 degrees.
5 degrees.
But you have to have a mechanical fixation if you have 5 degrees. You don't need a fixation if you have just 3 degrees, up to 3 degrees.
Perfect. What also is new is the rail. So you can see the rail is quite wide. This is interesting for the ballast because you can put the ballast directly into the rail. You don't need special parts. If you have less ballast, if you have a little bit more ballast, then you can use a speed porter, which you can just put on the rail. So this is a really good solution and a fast solution. And then most important is the new EPDM pad. So it's called in the price list MAD-V or in the product overview. This is really for compensating of tolerances. So if something is moving a little bit, so we don't talk about moving 1 meter, we're talking about moving 2, 3, 4 millimeters, 10 millimeters, then the mat V will absorb it. So you don't have a force on the roof.
Okay, that's true. And also the mat V is from recyclable materials. That's very good to know as well for some of you.
Yeah, recyclable material, and it has a really good friction coefficient. So you need less ballast than with our old system. And with the short rail system and the small parts, you can see in the picture, we have a lower transport volume, so we can reduce the logistic cost or the transportation costs. And it is really aerodynamically optimized. So we made a lot of wind tunnel tests. And after the wind tunnel test, we changed all the time a little bit in the design. And now it's really aerodynamically optimized. So you need also one more time less waste.
Okay, there are a lot of questions just now. For example, how you do it in the Caribbean, and what's the maximum weight and dimensions of the ballast? Like different questions. We can't answer all these questions now, but we will definitely get back to you. Okay, with the weight and the dimensions of the ballast, we will get to this point later on with the base on calculation. But with the Caribbeans, and we will talk to you by email later on. We will get back to you.
Yeah, we have your contact details or your mail address and can easily
answer the questions. Yeah.
So now let's have a look for the D-Dome system. What's the difference? Also, it's easy install. So you need only one screw for the system. We'll show you later on in a live demonstration. So we have the rail, which is the wide one. We have the mat V, and then we have the peak. So this is for the inclination of 10 degrees. We have the peak, and we call it the SD. So this is on the bottom side of the module. We need it on the bottom side of the inclination. We just have to input it, so we can, the module clamp, which you see on the left, just put in and fix the module. We use more or less the same parts for the Dome V system, so the peak is a little bit different because there's only one module on the peak, and we have one more part, which is the windbreaker. So the windbreaker we also can put in for reducing the ballast. We need less ballast. And this is also the reason why the peak looks different, because you can put the windbreaker in this area. Just fix it with a T-bolt and a nut, and then it's quite easy handling. So, two more references. One is Dome V system. It's in Germany, in Hanover, 200 kilowatt peak project. And the second one is a 700 kilowatt peak project, but it's a D-Dome system. So this is the east-west direction, also made in Germany. And as you see, during this installation, the weather was quite bad. What we have done, we prepared all the rails, not on the roof because of the bad weather. We prepared it inside of the building.
Inside the warehouse, easy and dry.
Yeah, easy and dry. And then we just put all the rails on the roof and
fix the modules on it, and it was done.
It was done. So you don't have to be all the time in the rain if the weather is quite bad.
Exactly. All right.
So let's change to the camera. Let's have a look
at the samples.
At the samples.
All right, let's
do this.
Live
demonstration.
Okay. Are you there?
Yeah.
Okay, we will start with the mat V. This is the original mat V, the same length as it always is, but I will show you how flexible it is with the short part. This is how it looks, how if it's absorbing the vibrations, the thermal extensions. This is the easiest way to absorb it. That's why it's very important. We got a very low friction coefficient with this mat V. Also, it's very easy to slide into the rail. As you see, this is the rail itself. Looks like a normal speed rail, just with two wings on the side to put the flagstones on top of it. Very easy to just slide it into the mat, and that's it. all our parts up front now, all our parts are like real life dimensions, except of the rails. They're of course longer and shorter. Okay, Matthias, you want to show them how to fix the base?
Yeah.
All right, let's do this.
We have our famous MK2 nut. You just take the rail and the nut and turn it in like this. You see, it's fixed, but it's still movable. I think this is quite important. Then just take the base. This is now for the D-dome system. So you can see you have for 2 peaks. Just take the base, put it on, 1 bolt. As I told already, you only need 1 bolt for the system. Tighten it up, and it's fixed. If it's not really tightened, it's also quite easy because of the wide rail. This is already fixed, so it's not moving in any direction. It's just moving the direction we want to move it. And if you fix it or tighten up the bolt, then it's fixed and it's not moving anymore.
It's easy. The only tool you need is a socket head wrench. That's all you need to fix the whole system. All right, this is the base of the V systems. Now we're coming to the peaks.
Let's go on with the peaks. So
they're looking the same, both sides looking the same, but now it comes.
Yeah, now the system is quite easy because you cannot make a mistake. So it should be installed like this. If you try it like this, it's not fitting. So there's no possibility to get it in. If you turn it, this is the right direction. This is how it should be installed. It fits easily.
That's right. Because of those 2 little wings, they're different sizes. You see this one, maybe you can see it in the camera. This one is a little bit thicker than this side. That's the way how you can't put it the wrong side. Very easy, just slide it in. And what we see here, before you slide it in,
this one.
Yeah, Matthias can show you this one.
This is the clip.
This is a clip for grounding and lightning protection as well. It will hold the peak right in the center of the base, also as it's scratching into the peak, and the same, it's the lightning protection and the grounding effect. You want to show it how to fix it in? I'll lift it up a little bit.
Just click it in. You heard it. You hear if everything is fine.
Click it in.
Then just
again,
take the peak.
The right direction, only one way possible. Slide it in, and it won't move to the left or to the right. Same on the other side. Do this one.
You can just do it.
And there we go. V system. How I remember always, maybe it's easy for you as well. We have the D-dome and the S-dome. D-dome is most of the time east-west side, but we also call it double dome. That's where the D is coming from. S is single dome. That's why it's always, we usually have it into the south direction, but we call it single dome, S-dome as well. Maybe easier to remember for you.
And for installing, it's completely the same. You have the base, it looks different. There's 1 bolt only.
Exactly.
And then you have the peak.
Exactly. The only thing is there's a wind shield on the back.
Yeah.
You always put a T-bolt in, fix it, and that's it. You have the windshield, you have the module this direction, and that's it. These are the peaks, but then to the whole system, there's also the SD dome.
Yeah, the SD part. As we told already now, sometimes you don't need a screw, or you only need 1 screw for the complete system. So for the SD, we don't need a screw. You can just do the same, just turn it in, and that's it. Now it's still movable because the fixation is done with the module clamp. Let's take the end clamp.
1 second before you go on. The clamps, I hope you all know them already. That's the same clamps as our mini rail system, our mini clamps. The range is from 30 to 50 millimeters of the module frame height. That's the same, exactly the same module clamp. Sorry, Matthias, you can go.
No problem, no problem. So this is now a sample of a module frame, what we have here. So just, I hope you can see it, just put the module clamp in, put the module on it,
you fix it, and by fixing the bolt, you will lift the whole thing up, the whole SD dome, and that's how you fix it onto the rail. So once you have tightened up this bolt, it shouldn't move forth and back.
Now it's
done.
fixed. You can
Just
see it.
fixed.
I can move the complete rail. Better, I can move the complete rail with just have my hands on the SD, so it's really fixed.
Exactly. That's how it's working. And at the end, you will just see the rails would be for the south direction, would be this way, and the module would be lying in here. That's how it's working.
One more thing, if you need the grounding of the module to the mounting system, we can have the Terra like this. I hope you can see it.
You can see it. Let me see. Yeah, that's good. You see the two wings on both sides.
And you can just put this on the module clamp. Also, it's just a click solution. And it looks like this. The best is if you do this at the middle clamp, because then you have the grounding for two modules. You can see it like this. For the two module, one module would be here, the other one here. Just turn this. And then just you can, let's take the S-dome, just put it inside.
Slide it in, put the module on top. It will scratch on the frame. That way the grounding is done. Easy.
So, easy solution.
Right. Okay.
Let's have a look.
Another advantage. One more second.
Yeah,
Another
sure.
advantage of the V system. If you're keeping parts on stock, it's easier to send them out. Like the freight costs will be lower. It's easier to pack them. It's easier to store them in the warehouse or wherever you store the parts. So that's another advantage of the V system. Okay, I think that's it with the parts. Let's do another calculation with base on. Let's do this. As we see, the roof is still in here, but we want to delete it out. Otherwise, we have two roofs now in our PDF file at the end. We'll just delete it by clicking the little X over here. And just move. We will still stay in Renningen, same street, Heinkelstrasse. And we know this is a flat roof building. We want to draw this roof now. Now we press the plus button again. Flat roof. This is rectangle as well, and flat. Draw the roof. Okay. Now this is very important as well. It's called flat roof, but no roof is very completely flat. That's why we always type in at least 1 degree roof pitch. It's important for the ballast. It's not like a big value change, but still, it's the best solution. The building height, we know we are on 8.5 meters here, and the parapet wall is 0.5 meters. Now, again, friction coefficient, very important. With the new Med V, the lowest we can actually go is on 0.5. It doesn't matter if it's a foil roof or if it's a bitumen. So it doesn't matter which one you have, you type in at least 0.5 or 0.55. If you have to still check it on the roof, on the side.
And the question always is how to check it. There you can just go onto the question mark on the top of the software.
Over here is the question mark. Press the button.
A window will open, and then you can see the fourth and the fifth. No, the third and the fourth lines are the coefficient friction.
Exactly.
And the fourth is the video of it, so you can just have a look at the video, how to measure the
friction coefficient. Exactly. So that's a little sidekick. That's good. Let's get back to the roof. Here you can see we have some obstructions and obstacles on the roof. Now we want to draw them. Go on obstructions. Draw one of them, which is this one now. Switch to 2D. Let's say this one is 3 meters wide and 4 meters long. This is where you can change the dimensions. And if you want to change the location of it, you can press this button. Show dimensions for edge distance. So we know this is right on the edge here. So we type in a 0, so it's right on the edge. And let's say this is 5 meters from the bottom. Type in 5 meters, and now you have the right position. What we do now, switch back to map view. We want to do another one. And those ones, now it's getting interesting. There are 2 with the same size. So you type in, again, with the 2D, the position where you want to have it. Back to the dimension. Let's say it's 3 meters long, 1 meter 50 wide. And we have 2 same ones of them. Sorry, I pressed into the roof. I have to go back to obstruction. Press this obstruction. And we are here, obstruction 2. This is the number 2. And we just copy it. And we have exactly the same dimensions again. We can move it onto the place wherever we want to have it. It's easy to switch to 2D to see where is the obstruction, where is the obstacle. And that's it. Easiest way. There are some more over here. We can just do a big one on top of it because we can't fit any modules in between anyways. And then, for example, you know, this one has a height of 0.3, so there's shading going this direction. So you can have an edge distance of, let's say, 1 meter next to it. It will show you where you can't draw, where you can't set any modules on the roof. Also, the obstruction height, let's say it's 0.5 meters. Just for example, so you see it. You can see the shading. Switch to 2D.
You need a date.
Let's go for, I think it's around Christmas time where you get the best shadings. Well, actually it's the worst for us, but start time 9 o'clock. Doesn't want to work now. 9 a.m. until, let's say, 4 or 5 p.m. And now you see the dark shading all around it. If you want to do like, let's say it's a chimney with 1.5 meters, you see the shading. Now you can see it clear. This is the shading. All right, these are your obstructions now. Remarks, we talked about that before. Now we've done the roof. We keep going with the design now, but just for you to let you know, well, handbag Q-cells again. We want to have the edge distance. This is the yellow line inside. So even though you don't have a parapet wall, you still need on flat roofs an edge distance. So you can only draw inside the yellow field your modules, just to let you know. You can still change it later on after you have set up the module field. So what we do now is drawing a Dome V, one of our new systems. You know all of them, all old ones. Those are the 2 new ones. It's landscape, portrait is not possible, you see. It's elevated 10 degrees, and then, like I said before, we go for the module field. Draw the module field, the whole roof. Okay, and now there is a note from base on. It says, you have planned a single module array. So a single one is not possible. That's why it's showing you in red with a little note on the side. The minimum array size is 2 connected modules. That means 2 domes, which means 4 modules. What's another advantage of the Dome V system? It's very clear here. Very clear. You see a very big module block, which wasn't possible with the old classic systems. That way you get very low ballast as well, as the mat V is helping with that. We want to have two really nice looking module fields again. So press the eraser on the left hand side, take this one out, take those ones out. Let's say this area, we don't want to have any modules here, they're not looking good, and get back to it. So Matthias, do you like the layout just like that?
Not really. It's really unsymmetrical. Look on the top right, there are only some modules because we have a thermal gap here. Maybe we can do it better. But let's have a look at the loads first, and on the ballast, I think this could be quite interesting. So the loads, I think we showed to you already with the standing seam calculation, still the same. And the results also, and now you can see we need a lot of ballast. We have 59 kilogram here. Oh, this is
this is not the best option.
It's too much.
Also, in this one single row, you have 17.5, 15.5, and 53 kilograms. That's just way too much. We don't need this. This is unnecessary weight on the roof. So shall we split it up?
Yeah, split it up. Let's change the thermal gaps. Maybe we can have a better solution.
Okay, let's go back to design then. Switch to 2D view and start moving the thermal gap again. Let's go for the first one. What we want to do is having a clear corner, which is what we have here already. So I would move this thermal gap onto this position. So we press this red line, tick the box, press the white line over here, untick the box, and this is looking already much better. What do you think?
Yeah.
Looking much better.
It's looking better.
So we have 1, 2, 3, 4, 5, 6, 7 in a row over here. 1, 2, 3, 4, 5 over here. You wanna mix them up more?
We can change it to 6 to 6, right?
All right, let's do this. So we wanna have the thermal gap over here. Press the red line again. Tick the box. The message is telling you again, you have one planned, you need two connected modules, which is that one over here. It shows you in red. So what we do now is just press the white line, untick the box, and the node is gone again. That way we have 3 module blocks with pretty much the same size, and they're looking good as well. Also, it's good for the ballasting. There's one more thing we could do.
Yeah, I think the line on the top is still, it's only one line. Maybe we can change this thermal gap too.
All right, let's change this one as well. What we want to do is now we have 5 and 5. So we have the same block sizes. Put the thermal gap in the middle. Tick the box. Press the white line again. Untick the box. And there we go. Now you see we have 8 pretty looking module blocks, I'd say. One mistake came up again. There were modules I didn't want on this position. They came up again, so I pressed the eraser again and delete them out.
Yeah, but now it looks really nice.
That's what I'm thinking too. Also, if you try to put your thermal gaps on positions like this, you are saving a lot of material. Let's say you want to have the thermal gap on this position. Always remember you need double the material for both sides, because you had one dome in the middle here, but if you have the thermal gap, you need it twice on every module. So that's a little hint. If you try to get them always where you have a little corner or where you have an obstacle, always try to put the thermal gaps on these positions. Let's check the loads again.
Well, let's check the loads. It was 59 kilogram in the last checking, right?
All right, we go loads. Still everything's fine. We know we're on the terrain category 3. We are in a suburb right now. We're not in the middle of the city, but we are not outside. Okay, let's check the results. It's calculating always. You can see it up here on the top right of the screen. And there we go. 0 ballast in the middle, and outside is only 1.5 kilograms. At the corner is only 10 kilograms and 11.5. So that's a very low ballast here.
Yeah, the maximum is only 20.
The maximum is 20, as you see.
So
You
it's
can't
there
even
in
find
small blocks.
Yeah, as you see, this is a smaller block, so you need a little bit more ballast, but it's still not a lot.
But Roman, how many stones do I need?
This is the new feature of Base On. We can change it now from the ballast in kilograms to stones, the number of stones. See it on the left-hand side, I changed it from ballast values in kilograms to number of stones. How much does a stone weigh? What do you think?
I think it's 5 kilograms.
All right, let's say we have a stone with 5 kilograms. And there we go. It will change up. The whole system shows you how many stones of your 5 kilogram stones you need on which position. I will zoom in a little bit more so you can actually see. We need 3 stones here, 2 stones here, and this is how it goes. Very convenient. There's a question coming in about the distances. The thermal gaps, I think that's what they were asking, right? Do you understand it right? Okay. The minimum or the maximum?
I'm not sure it's about the thermal gaps or it's just about the installation.
The SD dome. Oh, between the SD dome. Okay.
So I think it's more about the
This is the row spacing. There was a question about what's the row spacing. So the maximum row spacing is on 2.249 meters. Row spacing is the space from the first module until the third module starts. So this is the row spacing. Means let's show you. If you put 2.25 in, the maximum is 2.249. And you saw it on the screen, those gaps were getting wider.
Yeah, now this gap, you can see it's called a service corridor. Now this gap is almost 0.2 meters.
Exactly.
And if you change the row spacing, the service corridor will be less.
You can't really say the distance between the SD dome because it always depends on what's the dimensions of the modules as well. You can only type in the row spacing. Okay, I hope this was answering enough. One more thing, the lowest you can go is 2.19. Otherwise, you wouldn't get any shoe in there for maintenance or whatever you want to do in between the rows. Okay, let's get back to the result. The summary, the bill of materials, as you can see here. We have the peak and the base, the clip, very important as well. The MK2 nut, cable manager. You can, if you don't want the cable manager, you can change it here from cable clip to none. If you don't need it in your bill of materials. And the question from before, you can type in how much weight you want to put on the rail without the speed porter. So that's 30 kilograms. If you use the speed porter, that's another 10 kilograms. And then there are the porter, which is the L profile in the middle. You can add another 120 kilograms on it.
There was one more question. Can you have different stones, 5 kilogram and 10 kilogram?
Of course, you can type in 10 kilograms.
You can type in 10. If you have now 5 kilogram stones, you have just to put a double number on it.
Exactly.
At the moment, it's only possible to put one weight of the stone inside. Later on,
maybe they will implement it, but not for now.
In some new releases, we will have the possibility, but not at the moment.
Only one weight of the stone, no mix-up so far. But you can change it from 10 kilograms to 8 kilograms or to 2 kilograms, however your weight, the weight of your stones is. Okay, so last but not least, we go for the PDF file. I will show you something about that. Again, you see this is the project, date and an author, then general informations again, and now it's becoming very interesting. When we said before, you can set up the whole system inside the warehouse or somewhere else. This is what we meant. There are now 4 types of rails, type A, B, C, and D. And what you can do is fix the rails with, let's say, 2,650 millimeters, take the rail and put the peak on the right position. The first position would be distance A, which is in this little table out here, 996 millimeters. For the second one would be B and D. B would be 165. In the middle between the peaks, you would need 2060, and then there's the distance B again at the end. Same thing for type C. Distance C has to be 158. And the last one, type D, distance A again, which is 996, and then A1, which is 374. This is how you can set up all the rails you need, and then go onto the roof, set it up with the modules, and it's all fixed and done. The rail placement is shown right here with 4 different lengths, with three domes behind each other, 5, 6, and 7. Okay, the next one will show you the layout. The layout itself, how it looks with the modules. Okay, and then we come to the next page where you can actually see where the rails have to be placed.
So this is now quite interesting where the rails have to be placed. So you can see we have a rail with 6 modules. So if you go back 1 page, at the moment we have small problems with the computer. Let's
just keep it low. The computer has enough for today.
If you go back, so this is the 6. So you need this
setup,
this line, this setup
on module block 3.
On module block 3, and you see the dimensions. So it's 8.55 meters wide, and you need it 1, 2, 3, 4, 5, 6 times. In this case, you can just put it in, and you don't have to be really accurate while positioning the rails, because you can just, if you put on the module and you fix the first module, and just take, maybe you fix it on the right side, then just take the rail from the left side, put it next to the module, fix it, and that's quite easy. So it don't have to work like on millimeter.
Like you had to do with the long rail system. That was always a problem. With the long rail systems, you have to be very accurate by setting it up with the installer. Okay, let's keep going with the next page. This is where you see the table, the module blocks with the amount of stones you need.
Yeah, you see in the middle you don't need stones, then you need 1 stone on each dome. Let's go on.
Do you want to explain that?
Yeah, I can explain it. So this is quite interesting. This is now the module block or the module array 1. We have 35 supports on this or in this module block, and we need a ballast for this module block of 136 kilograms. And the complete weight, so the complete weight means the ballast, the mounting system, the module, all together.
Everything, the clamps, everything on the roof for this whole block.
For this block will be 1,627 kilograms. That's why it's so important to put in the right weight for the modules.
Exactly.
Because the weight of the mounting system we can calculate, we have it, but the module weight depends on which module you choose. And we have a load in a kilonewton per square meter.
It's 0.12, and that's very low. Let's say the ballast reserve on some flat roofs are from time to time, customers are coming up and say, oh, we have only 20 kilograms left. Do you think you can do this with your module layout? And we just draw, pretty much we calculate the base on calculation. It will show you 0.15, that means 12 kilograms per square meter, and that's the best you can do.
Yeah.
You can't get any lower. What do you think?
I think this is not really high. It's quite low.
For the whole system, not high at all.
No.
And then you see on the right hand side, the last one would be also the weight per square meter, but this is for the whole roof. Also for the aisles you're having, also for if you have obstacles. Yeah, exactly. For everything. This is for the whole roof, even though there are no modules on it. All right, what else?
Well, let's go on. This is now the calculation. I think we'll not go in detail. If you want, you can have a look. This is the next important thing. The system has been successfully calculated. So
very important again. Once you've done that, you got the warranty and everything. Perfect. And then we got the bill of materials in the very bottom of the PDF file. Okay, I think that's it. Do you have any more questions? Please ask them now. Otherwise, we want to turn on the camera again. All right, I hope you liked it. There are no questions for now.
No, I don't think so.
We will stay a few more minutes and wait for your questions. If not, thanks for listening. Thanks for watching. Anything else to say?
No, I hope you liked it and you will join in for the next webinars.
That's right.
And what quite interesting, we are almost in April, and in May we have the Intersolar in Munich.
Exactly.
So if you visit Intersolar, you can just visit our booth. We will be there.
Come over, talk to us. We're happy to see you and meet you.
That would be really great. I'm just looking.
More questions?
No, I think it's not a question. It's more a thank you.
Okay.
So,
all right.
Thank you very much.
Thank you.
Have a good time. Bye.
Bye.